limits. This genius guy, Atterberg, realized that clays, something very weird happened to clays when they are mixed with water. Okay? And pay attention to this, please, because it has a lot of concept, more than just how to do it. What did he realize, Atterberg? He realized that if you get a clay sample, put in a bowl, put it in the oven, dry it up completely, it becomes like a piece of rock. Correct? Imagine you get a clay sample, chunk, put it in the oven 24 hours, take it out, it's going to be really like a piece of rock. If you hit it, it will crush. Then he started adding water to it and trying to mix this water with this clay powder thing, or with a chunk of clay that looks like a rock, and tried to mix it with the water. Do you think it's easy to mix it with the water when it's almost like a rock and doesn't have any water? It's going to be easy to shape it and mix it? No. Then he started adding more water, and again try to mix this water with this clay that feels like rock. When you add more water, he realized it's getting easier to mix it with it. Then add more water, and getting more easier. Adding more water, it becomes almost like a plastic clay, like a Play-Doh that the kids play with, right? That's plastic clay. Then add more water to it and mix again. It becomes very, very thick mud. Add more water, it breaks more and more. Add more water, it breaks until it becomes like very watery material, like a mud basically, like almost a liquid. And then he thought back, what did I do? What did I do to this clay? All what I did is increasing the moisture content. So his conclusion was, this clay, this water, has a detrimental effect on the shear strength of the clay. And he gave us these genius limits, Atterberg limits. Look at this curve here. That's what he did. Zero moisture content. This is a moisture content. Zero moisture content, right? Going, filled all the voids with moisture, and then start to increase the whole volume of the thing. So D, C, B, and A, all these specific moisture content, he realized that the clay changed condition from being almost like a solid material to semi-solid, to plastic, to liquid. So he defined these specific moisture contents and called them shrinkage limit, when the clay changed from solid to semi-solid; plastic limit, when you change from semi-solid to plastic, like a Play-Doh; liquid limit, when it changed from this plasticity into almost a liquid. And these are what we know today as Atterberg limits. So they are limits that define the change of state of the clay from a condition to the next worse condition. Every state has a specific shear strength of this clay. Now, he also defined something great for us. He said, if you take the plastic limit, the liquid limit minus the plastic limit, this range is called the range of plasticity of the clay. So liquid limit minus plastic limit, he gave it a name, plasticity index, PI. And that defines how big is this range of the clay plasticity. Very, very important when you deal with shrink, swell material and consolidation and stuff like that.